right, we are continuing right now with everything we talked about yesterday. Here's a quick overview of what we learned yesterday. Whenever you have a plus bi and you multiply it to a minus bi, that always becomes a squared plus b squared. That was what we talked about yesterday. Okay? We're going to use this concept to build a polynomial function where we have this root, and this root. What I want you to do right now is set it up with, we're going to say x minus, I'm going to open up a parentheses, and I'm going to plug in a negative 5. And when you do that, the factor becomes x plus 5. The next one we're going to do is we're going to do x minus, I'm going to open up a big old parentheses, and I'm going to put 1 plus radical 11 I over 2, and I'm going to close it, because all I've done is take this one and plug it in. And the last one I'm going to do is I'm going to say x minus, open parentheses, 1 minus radical 11 times I, all over 2, and I'm going to close this parentheses. Okay. So I'm taking this root and I'm plugging it in. Just remember, if you have roots a, b, and c, A, b, and c are any number, your function will always be x minus a times x minus b times x minus c. That's what f of x would equal. If these were the roots, all of these would be the factors. And that's what we're doing. We're building it, and then we're going to be multiplying things together. Now this one was easy. That just became an x plus 5. The one that's difficult to multiply is this right here. Okay? So we're going to take our time, and we're going to multiply things out nice and neat. So right now I'm going to go down here. I'm going to make it nice and big. We're going to do the FOIL method. We're going to say x minus. We're just going to take our time and work it out. So if you have somewhere to go, you might want to put those plans on hold. Just saying. If you want to run away, now would be the time. Just kidding. Stay where you are, Cody. Don't run. All right, so I realize we have a whole bunch of parentheses. We're just going to do the FOIL method, okay? We're going to focus on this guy and this guy. So we're going to focus on just FOILing it out. Okay? X times x is x squared. Now, the next thing I have to do is I have to take this x, I need to multiply it out to this guy right here. I'll highlight him in a different color. So if we multiply x times this, you are left with a negative x times 1 minus radical 11 times I over 2. Now we have to multiply to the inside, right? We've done the first, we've done the outside, now we're going to do the inside. And once again, what do you have? It's going to be a negative, so it's going to be a minus x, except this time, what's going to be inside my parentheses? It's not going to be a 1 minus, it's going to be a 1 plus. I'll put 1 plus. Radical 11 I over 2. And then the last thing we multiply is this times this. Now, this times this, a negative times a negative equals a positive. But how in the world do we multiply a1 plus radical 11I over 2 times a1 minus radical 11I over 2. So right now, this is all the math that we're going to be doing on this problem is right here. And what we're going to do is we're going to break it down into two things. What's the easiest one? The easiest one is we just drop down the what? Drop down the x squared. So let's just do that. Get that taken care of. Now we have an x squared. Now what I'm going to focus all of my attention on in this video, I'm taking all of the attention, I'm going to focus on just that. So we're just going to focus on how do we get just that done. Okay? All right, I realize there's lots of math up here. Right now I just want you to focus on this box. Okay? Right now, what I'd like you to do is take this negative x, and I'd like you to multiply it to the 1, and take the negative x and multiply it to the negative radical 11i. So when we distribute, what I'm going to do right now, I'm going to change colors. I'm going to distribute that in here and to this. We're using the distributive property. So what's a negative x times a 1? That becomes a negative x. And what's a negative times a negative? That becomes a positive. And I have a radical 11. And then there's an I, right? So I'm just going to put an I, and I'll just put an x next to it. And what's that all over, everybody? That's all over a 2. All right? So that's what we have right here. Now, I'm going to do this one. I'm going to distribute negative x into both of them. What is a negative x times a 1? That's still a negative x. And what's a negative times a positive? That's going to make it a negative 11ix all over a 2. Now I realize these right here still look pretty complicated, okay? So let's break this down. I'm going to break this down into a negative x over 2 plus a radical 11 times ix over 2. On this one, I'm going to break it down to negative x over 2 minus radical 11 times I times x over 2. Now, if I do this, hopefully you can see that we have a positive radical 11ix over 2, and we have a negative radical 11ix over 2. These are like terms. These right here, everybody, actually cancel each other out to 0. So this cancels out to a 0. What am I left with now? I'm left with a negative x over 2 and another negative x over 2. So what does negative x over 2 mean? Basically, it's like saying I have a negative half of x and I have another negative half of x. What do those combine to? Negative half of x minus half of x more. That makes it a negative x. So let me explain what our answer is. When I took all of this and I took away all of this, what I eventually ended up with was just a negative x. So what do we have now as far as our answer is concerned? We have an x squared and a what? And a minus x. All right, now that we have this, what we're going to do is we're going to go over to this area right here. Okay. So right now, I want you to focus all of your attention on how to multiply those together. So I'm going to go over here where I got a little bit of room. What I'd like you to do, I would like you to break it down. We're going to say 1/2 plus radical 11i over 2. And we're going to multiply that to 1/2 minus radical 11. Now I made make sure the I is on the outside of the radical, not on the inside. Times I over 2. Now yesterday, we talked about a very important pattern. Here's the important pattern. If you have an x plus 1 times an x minus 1, that becomes x squared minus 1. Why is that? Because all we have to do is focus on the first term and the what? Last. So all we have to do is focus on the first and the last, because we know everything in the middle cancels each other out. That's what we learned yesterday. So right now, all I'm going to be worrying about right now is the first term right here. So we're going to multiply a half times a half, and a half times a half is 1/4. And we're just going to worry about the final or the last terms being multiplied. And I'm going to multiply a radical 11 times I over 2 times a negative radical 11i. Now here's what's going to happen. I'm going to set them up right next to each other. How do you multiply an 11i over 2 times a radical 11i over 2? Now you're like, Mr. Moody forgot a negative. Basically, a positive times a negative is going to stay a negative, so I just left the negative in. All right, we're going to be multiplying these together. What is a radical 11 times a radical 11? What is that equal to? 11. That's just equal to 11. Okay? What is I times an I equal to? From yesterday, that's equal to an I squared. But what is I squared always equal to? Negative 1. Okay? So right now, if I say, what is 11 times a negative 1? Oops, sorry. If I say, what's 11 times negative 1, what are you going to say it is? Negative 11. And 2 times 2 is 4. If I have a negative and a negative, that makes it a positive. And we got what? We got 12 over 4, which equals 3. Now, what did I say we could do in the calculator? I said in the calculator, what you guys can do open up the parentheses, hit alpha, y equals, enter. Okay? Do 1 plus radical 11 I over 2 times alpha y equals, enter. 1 minus radical 11 I over 2. And when you press enter, what do we get? We get 3. You multiply them together. What do we get by doing it by hand? Still got the number 3. So everybody, the final thing we're going to add to this is we're going to add a 3. By the way, this right here, we're going to take this answer right here and we're going to multiply it to x plus 5. So what I want you guys to do right now, okay? What I want you to do in your journal, take x plus 5 and we're going to multiply it to x squared minus x plus 3. So right now we'll write this out. Just remember, what was the root for this one? It was a negative 5. What were the roots to this one? The roots to this one were these right here. Those were the roots that got us this equation. Okay. Here we go. We got to do the FOIL method. What's x times x squared? 2. What's x times a negative x? Negative x squared. What's x times 3? 3. 5 times x squared. 5x squared. 5 times a negative x. 5x. 5 times 3. 15. Whatever you get here is your final answer for what f of x is equal to. It has 2 imaginary roots and 1 real root. The real zeros was at a negative 5. The imaginary roots, or the imaginary zeros, were at a 1 plus radical I over 2 and a 1 minus radical 11I over 2. Those were the roots. So in summation, you took this real root and these 2 imaginary roots and you built it into a function. All right? The next problem is a heck of a lot easier than this problem. Number 10 is very, very easy. It's going to be an x minus 1 times an x plus 1. It's going to be an x minus a radical 3 times I and an x plus radical 3 times I. Because if I take away this one, if I take away a negative, it makes it a plus. So what I'd like you to do, I'd like you guys to multiply these together and then attempt to multiply these together. Just remember, when I say a plus b times a minus b, that becomes a squared minus b squared every single time. This is called the difference of squares. And we've done this before. If I had x plus 2 times x minus 2, that becomes x squared minus 4. Okay? So why don't you guys right now pause the video, try to solve that on your own, see what you get. Just remember, the I is not on the inside of the radical, it's on the outside. It didn't do a very good job of writing it. So what did you guys get for this one right here? The easy one. What'd you get? X squared minus 1 is right. Very good. Because when you guys do this, notice what happens. You get x times x, and you get negative 1 times 1. What's going to happen when you multiply an x times a 1 and a negative 1 times an x? They're going to cancel out in the middle. So what we worry about is the first and the last. Let's just worry about the first. What's x times x? X squared. Let's just worry about the last. Okay. We've got a negative, right? Yeah. A negative radical 3 times I, and we have a what? A positive radical 3 times an I. So here we go. We have an x squared minus, what is radical 3 times radical 3? 3. Very good. So that's going to be a 3. What is an I times an I?
I squared.
I squared, but wait. That's right. I squared is negative 1. Right? So we had to multiply that by a negative 1. So I basically have an x squared minus a 3 times a negative 1. Alright, by the way, can I give you guys some patterns you can just write in your journal so you're like, okay, this should make sense. Here we go. What were the factors of x squared plus, what were the imaginary roots? They were what? A 3i and a negative 3i. If I said x squared plus 4, what would the imaginary roots be? They would be a plus, a 2i, or a minus a 2i. Because what's the square root of 4? 2. If I said x squared plus 5, the roots would be a plus radical 5i and a negative radical 5i. x squared plus 6. A plus radical 6 times I, and a minus radical 6 times I. Now, I'm used to seeing that. Honestly, I'm used to seeing I radical 6 and a minus I radical 6. That's what I'm used to seeing, okay? Okay, one more. X squared plus 9. Is that a perfect square?
Yeah.
So that would be a plus or a minus what? Plus or minus 3. Okay? So automatically, guys, when I saw this problem, I immediately knew, without having to do any work, I knew that was going to be in x squared plus 3. So here we go. We got to take x squared plus 3 and multiply it to x squared minus 1, and we're done. What'd you say? X squared minus 1 times x squared plus 3, and we're done. So write it down. There you go. All right, Haley. X squared times x squared. Good job. All right, x squared times 3. Good job. Negative 1 times x squared. Notice, I put that directly underneath the other x squared because they're not. And then negative 1 times 3. Let's add these suckers together. Our final answer, everybody. All right. F of x equals x to the 4th plus 2x squared minus a 3. This guy has 2 real roots. What were the real roots? One was at a negative 1, and one was at a positive 1. And then the other one was a plus I radical 3 and a minus I radical 3. And then they say radical 3 times I and a same thing. So understand, you might see it, I'm used to seeing it as I radical 3 and negative I radical 3, not where it's at U. So these were the roots. Remember, these were the roots, and this is our polynomial function. Okay? And yes, now if you have something to do, now that you've written this down, you can go on with your life. All right? You survived.